Okay, so we're going to talk about adding fractions now. When you add fractions, you need to have the same sized piece. For example, if it's 1/4 plus 2/4, that makes perfect sense. I have 1/4, 2/4. So altogether, how many fourths do I have? I have 1, 2, 3. I have three what? I have 3/4. Okay, so the numerator literally means to number. Denominator is kind of like denomination. It tells you what sized piece you have. But as long as I have the same denominator, I can just add the numerators and retain the denominator. So I'll practice the same thing here, though this looks more complicated for problems 52 through 57. Um, we have the same denominator, so I'm just going to retain it. Okay, just retain it. And adding and subtracting will be used interchangeably here. When you subtract, you do want to change it to addition, and you want to change the signs, just like we had done in past exercises. Okay, so notice that positive 3x squared is now negative. That negative 9 is now positive. I can now just put that together as one fraction, retaining that denominator and writing my top in standard form. Negative 3x squared, negative 1 plus 9 is positive 8. Okay, so the top is not very satisfying there, but I've retained the denominator. I really didn't have to do a whole lot here other than just simply combine the tops. Now, when you don't have the same denominator, you'll need to find something called the LCD. Okay. Now, the LCD can be thought of as in different ways. Sometimes it just asks you to find the LCD, like 57 through 63. And there's multiple ways of doing it. Probably the easiest thing to do is divide the product by the GCF. Okay. The product divided by the GCF. So now LCD, technically it's LCM here because there are no denominators. D just stands for denominators, least common denominator, least common multiple. I'll use LCD here because that's typically what we're going toward. Product over GCF. So the product here, 4x times 8x squared, we'll multiply those. That's 32x to the third, right? 4 times 8 is 32. X times x squared is x cubed. That's the product. The GCF, we're already good at that. The GCF of 4 and 8 is 4. And pause if you need to. What's the GCF? How many x's can I take in GCF? You only take 1, right? Because what's the greatest thing I can take from both? I can take 1 here. I could have taken 2 here, but this one only has 1. And the common there, the C, means I have to take the same amount from each one. So it's going to be 32x cubed divided by 4x. 32 divided by 4 is 8. X cubed divided by x is x squared. Okay, so it just so happens that the LCD matches the larger of the two, which that will happen in some cases. Down here, you'll need to factor this one. Okay, factoring is definitely a skill you need here. We want to factor x minus 7, x minus 5. Okay, remember negative 7 times negative 5 is 35. Negative 7 plus negative 5 is negative 12. Now, same thing. Product times GCF. So what's the product? Well, you're just going to multiply them all together. X minus 5, x minus 7, x minus 5, divided by the GCF. What's in common to these two? Well, x minus 5 is. Okay. Then they'll cancel. So my LCD here happens to be x minus 5 times x minus 7. So this is my LCD. And you'll need that LCD to be able to add when fractions do not have the same denominators. Okay, again, pause and rewind is necessary on this video. I'm going to go back to this situation for a minute. Let's say that I had instead 1/4 plus 1/2. Okay, why is it that you can't just simply and quickly add those? Well, I have 1/4 and 1/2. I have one of each piece. Problem is, they're two different size pieces. So I don't have a clear denomination, or in short, a denominator. I don't have the same denomination or denominator. I need the same size piece or the same denomination, if you would, to be able to add those together. So that's when I take this and I slide it into fourths by cutting it in half again, and it goes back to what I had originally. I multiplied my pieces by 2, and that caused that one shaded piece to also be multiplied by 2. Okay, and I had the same problem as before. Now 1/4 plus 2/4 are the same denomination. They're all quarters. I can just simply numerate or tally them up. So you see the words numerator and denominator. It's a little more complicated here, but the same principle. You have 2 different denominators. So I need a common denominator to be able to add them. Okay. And again, if ever in doubt, just factor. X minus 6 won't factor. Okay, so I'm going to factor this, and factors of, and that's a typo, excuse me, that should be a 3 and not a 9. Okay, so that was a typo there. The factors of negative 18 that add to give you negative 3, that would be x minus 6, x plus 3. Now you can think of this 2 different ways. And probably the easiest would be just to look at each fraction and say, okay, what could I do? What's the easiest thing to do to make these have the same denominator? Well, they share this x minus 6. So if I could just somehow give this fraction x plus 3, they'd have the same denominator. And in fact, that's what I am to do here. I'm going to give it this x plus 3. Now, of course, you can't just randomly put an x plus 3 somewhere as you've changed the problem if you do that. But fortunately, here I can get compensation. Okay, so if I multiply the bottom times x plus 3, I can multiply the top by x plus 3. And notice these x plus 3s would cancel if I wanted. Now, I don't want to cancel them here because I'd go right back where I started. But you can see, because I got compensation, I included something on the bottom, but I matched it on top. So I'm not changing the problem. It's changing its value anyway. I'm just changing the way it looks. Okay, so this is good compensation. So now I have the same denominator, just like the 1/4 plus the 2/4. I can add once they're the same denomination or the same denominator. I can't add if they had different ones. Okay, so now I can just make it one big fraction because I've declared the denomination I want to use, or the denominator, the size piece, if you would, if you're thinking about pizzas or pie charts. Now, this might seem a little bit contradictory, but we typically leave that LCD here and we just don't mess with it. We don't distribute it together. You can if you want to, but it's typically just left. But we don't leave the top. I know it might seem a little bit contradictory, but it's typical to simplify the top as much as possible. And often, though sometimes you will, often we don't mess with the bottom. Okay, so running out of room here a little bit. That's 21x plus 22, check my math, x minus 6, x plus 3. Again, that bottom you could multiply together if you wanted to. But to recap that, I found the LCD. Or actually, I didn't go through the same process that I did before, which that process would have gotten you to this. There are other problems where finding the LCD might be a little better before just looking at it. But here it's easy to see if I put an x plus 3 on top and bottom, I've got my matching denominators. I then clean up the tops by distributing combined like terms. I generally don't mess with that bottom once I've established that. So that's how you add rational expressions or subtract rational expressions with different denominators.